aje when God was the Most High come.
Amen. All right, so we discussed rational functions, and today I just want to complete about graphing them, of which I believe I already started with you guys. So remember, rational functions are simply functions that can be expressed as a fraction, right? So whenever you have a, okay, let me just get my pen. Right, so remember any function, for example, we have f of x is equal to 2x plus 1 divided by, we can say 4x minus 3. Such a fraction is a rational function because it is expressed as a fraction. So remember, if you want to graph such a function, okay, they're definitely going to give you this. They'll ask you to find the domain of this and sketch this graph. So now when you're given such a graph to sketch, I said you need to find two things. And the first one is called the vertical asymptote. Okay, so you find the vertical asymptote, then you also find what is known as the horizontal asymptote. Then I'll show you how to graph these two things. Once you have these two things, it's easy for you to sketch this graph. And actually, it's even easier than sketching the other ones. In the next class, we're going to do quadratic equations. So I'll show you how to complete the square, then from there, how to graph the functions. So using this, if you want to find the vertical asymptote, I said in the previous class that finding the vertical asymptote, you're simply finding the domain, the numbers that are not in the domain. So want the x values that are not present in the domain. So to find this, we know that the bottom part, to find the domain, the bottom part should not be 0, isn't it? So I want to find the zeros of the function. So which ones will give us 0? So we need to get the denominator and equate it to 0, then find the value of x. So just get the denominator. This is 4x minus 3, right? Is equal to 0. Then we're going to say this is 4x is equal to 3. So therefore, divide this by 4. We're going to say x is equal to what? 3 over 4. So this 3 over 4 is what is our vertical asymptote. So our vertical asymptote in this case, you're going to say vertical asymptote is x is equal to what? 3 over 4. And this is your vertical asymptote. If you have been given whatsoever function, let's say, for example, we have another one. Let's say you have been given 1 over x, and they ask you to find the vertical asymptote. Remember, just get the denominator and equate it to 0, then find the value of x. So we're going to say x should be equal to what? 0. There's nothing to solve here. So your vertical asymptote is simply x is equal to what? To 0. There's nothing there. So that is all that is there when it comes to the aspect of finding the vertical asymptote. Okay, I hope that is okay. Then now, let us go ahead now and find the horizontal asymptote. So to find the horizontal one, okay, so to find the horizontal asymptote, so remember the word is asymptote, of which I defined this is a line that a function approaches but never gets to meet. So we have got the asymptote. So remember for the vertical asymptote, it can either be, you can find two of them, but for the horizontal asymptote, it's always that you're going to find one. So now for the horizontal asymptote, I said you need to check the bottom and the top there. So, okay, let me just give you this. So if, for example, you have got f of x is equal to, let's say you have got a general function a, x to the power, I gave you n the last time, I believe. Okay, a to the power m, this is a general function, over a, x to the power n. Okay, so now you need to check the power of x. Okay, which one is heavy? So if n is greater than m, we said this means that the horizontal asymptote here will say y. Okay, if n is greater than m, we're going to say y, the horizontal asymptote will be equal to what? 0. But if the n, okay, if we have the n being less than the m, then we're going to say there is no horizontal what? Asymptote. Okay, then the last situation is where you have them equal, isn't it? So n is equal to m. When these powers are the same, then you're going to say the horizontal asymptote, you're going to find it by dividing. So let this be b, okay? So b x to the power n. Then you're going to divide the horizontal asymptote. Here, this one will be equal to what? You say y. Y will be equal to, you divide the coefficients a divided by b. Okay, so let us do a practical example. If you have been given to find, for example, you have f of x, you have been told to graph f of x equal to x minus x squared minus 9, like this. Okay, let me probably reduce the, if I've been given f of x, okay, let me just erase this. If you have been given f of x equal to, so f of x being equal to x over x squared minus 9. And you have been taught to graph this. So remember, the first one is you need to find the vertical asymptote. How are you going to find the vertical asymptote? Right here, the vertical asymptote, you just get the down part. It is x squared minus 9 will be equal to 0, meaning x squared will be equal to 9. Then we're going to square, you can square root both sides, isn't it? To get, so square root this side and this side, we're going to say x will be equal to plus or minus what? 3. So these two numbers are your vertical what? Asymptotes. What about the horizontal one? The horizontal asymptote, we're going to say y will be equal to what? So you check the x values. Which one is the power? Check the powers. If the power of the bottom is greater than the power of the top part, so you can clearly see here that this is x, meaning it's to the power 1, then you have got x to the power 2. So you can see that the bottom part is heavy, isn't it? So since it's heavy, remember what we did? We said that if n is greater than that one, you follow what I gave you, you're going to see that the horizontal asymptote here will be equal to 0. Why? Because the highest power of the bottom is greater than the highest power on the top part. So your horizontal asymptote there you would have found to be what? To be 0. Okay. Then the other part that we spoke about is, what about when you're given something like this? When you have, for example, y being equal to 1 over x plus 2, then you have minus 3, for example. So this minus 3 is alone. Why is my handwriting becoming bad? Like someone I know. Okay, so let's say you have been given this. You have y is equal to 1 over x plus 2, then you have minus 3 here. So how do you find the vertical asymptote? It's the same way. The vertical asymptote is just the zeros. So the vertical asymptote, we're going to get just the bottom part, x plus 2 should be equal to 0. Then you're going to find x is equal to negative 2. So this is going to be what? Your vertical asymptote. What about the horizontal? The horizontal asymptote, when you have a separate number here, it's going to change a bit. So you find it the same way. The horizontal asymptote, you find it the same way here. We know that here you can check so this means there's a 1 here. So it means this is the same as x to the power 0, isn't it? Because any number raised to the power 0 is 1. So whenever you just see a constant, it means there's x to the power 0 there. I believe you know this. So now when you check here, this is to the power 1, right? This is to the power 0. Which one is bigger? Obviously, it's clear here that you can see that x to the power 1 is greater than x to the power 0, isn't it? 1 is greater than 0. So it means our horizontal asymptote here is going to be what? It's our 0, but you include this part here. So you can see there's a minus 3. So you say minus 3. Then you're going to have what? Your horizontal asymptote being equal to y equal to negative 3. So it's going to be like this. Okay. What about if you have something like this? The same way, if now, let's say we had x. Okay. Let's say now we have another one. Let me just cut this. Let's say we have x to the, let's say we have 2x to the power 3 divided by x to the power 3 minus 2. Okay, let's say, okay, let me put squared here so that we don't waste time. Okay, so let this be squares. Round of three numbers here. So let's say we have 2x squared plus x divided by, let me pick 4. 4x squared minus 3. Then we have a plus 4 here. So how do you do this? To find the vertical, obviously just equate the bottom to equal to 0. But for the horizontal asymptote here, that's the only one which is going to be a bit different. So for the horizontal asymptote, you check the powers, which one is the highest power. So at the bottom, the highest power is x to the power 2. So the 2, then the top part, we're going to have x to the power 2. So you can clearly see here that they are equal. And we said if these powers are equal, you get their coefficients, divide their coefficients, right? So we're going to say the horizontal asymptote y will be equal to, so the coefficient of the top part is 2. So we're going to say 2 over the coefficient of the bottom part there is 4. So you're going to say 2 over 4. So this will be equal to what? 1 over 2. And this is your horizontal. Now, 1 over 2, this is for this part, right? Then we have a plus 4 here. So we're going to say 1 over 2, then we're going to say plus this 4 here. Then you simplify it and get that fraction there. Okay, so I hope it's okay. So whenever you have a number separate here, it says plus a 4. You get the horizontal asymptote the way you got it, the way we get it normally when you just have a fraction like this. Then you add this number here, or you subtract this number depending on the sign. So if it's a minus, you put a minus. Okay, so I hope we are all clear about finding the horizontal asymptote and the vertical asymptote. Then the next let's just now look at how you get to plot them. Okay, so let's start with the simplest one, which you might be given as f of x is equal to 1 over x. Okay, so when you have f of x is equal to 1 over x, how do you plot this? So remember the two things that we need. The first one is the vertical asymptote. Then the second one is finding the horizontal asymptote. So we have 1 over x. So let's say we've been given f of x is equal to 1 over x. So the first thing, we find the vertical asymptote. So we're going to say vertical asymptote here, the zeros of the denominator. So we're going to get the denominator and equate it to 0. So we're going to say x will be equal to what? 0. Because it's already, there's nothing to solve here. So the vertical asymptote, we found it's equal to 0. Then what about the horizontal asymptote? So to find the horizontal asymptote, remember, you check the powers. So if there's a number constant there, we know it's the same as x to the power 0, isn't it? So you can clearly see here that this is to the power 1 and this is to the power 0. So meaning here, horizontal asymptote y will be equal to what? Will be equal to 0, because the coefficient, the x power, the highest power of x in the bottom is greater than the highest power of x on top. So after getting this now, the only thing that we need now is to graph using this information that we have. So what we need to get our x or y plane. Okay, I'll get my ruler. I hope this will be straight as I want it to be. So we get our ruler there. Okay, so we have got these numbers here. We can put up to maybe 3, the 1, 2, 3, and the 4. I think this will be enough. Then it goes on. This is a Cartesian plane, the same one in grade 12. Then here we can have some negative numbers, 1, 2, up to 3. In this side as well, I can just have 1, 2, 3, 1, 2, 3. This side as well, 1, 2, 3. I believe if you're using a ruler, you can use the centimeters and let it be equal. Okay, so we have this. Now, how do you sketch this? So the first thing we need to sketch is our vertical asymptote. So what is our vertical asymptote here? It's x equal to 0. So you go to x equal to 0. Let me pick a separate one. X equal to 0 is where? X equal to, when x is 0, we know that it's all this line, isn't it? So x being equal to 0 is at this point here. This is x equal to 0, isn't it? So now you shed and you put down, okay, let me pick something that's not close to this, maybe black. No, not black, maybe this. Okay, so you shade this. This is your vertical asymptote. X is equal to 0. So where x is equal to 0, you come vertically like this, you go down. Okay. So if, for example, we have this x or y plane, then they find that the vertical asymptote, for example, is equal to x is equal to 2. So you go to 2, 1, 2, then you come to 2 here, and then you just put a line like this. This is just a line that you draw. That's all. Just let it be down straight like that. So that's how you draw it. There's nothing complicated. So this is our vertical asymptote. It's x equal to 0. So we go on x equal to 0, then you put it down like that. What about the horizontal asymptote? The horizontal asymptote, meaning now this is horizontal, isn't it? This is vertical, so horizontal, vertical. So the horizontal asymptote is y equal to 0. So you go on y equal to 0, then you just put it like this. So y equal to 0, it is this. So I'm passing through like this. Okay, it's y equal to 0. Then like that, you would have drawn there. You would have drawn what they needed. The last thing now you need to do is plug in. So remember, I told you that the rational function is either going to be like this, right? Or it's going to be like this, where it's going to attempt like this. Or it will be like this here, right? Or it's going to be like this. So either of these is only two are going to accept here, but I'll show you how to do it. So now you come here. So you go to your vertical asymptote here is going to be the key thing. So you check your vertical asymptote. Here our vertical asymptote, we said x is equal to what? To 0. So you check now, pick any point to check where you're going to plot this, whether it's going to be like this or this. So you check your vertical asymptote. Here it's x equal to 0. So what you do is come up with a table of values the way we used to do it in grade 12. So you can pick your x and you have your y here. So pick any number to the right of the vertical asymptote, and then you pick any number as well to the left of the vertical asymptote. That's all that you need to do. So let me probably draw it here better. So if I have my x and my y, so now let's pick this if we are choosing a number to the right. So we have x equal to 0. So what number can we choose to the right? Yes, Joyce, which number should we choose here? To the right of 0. Which number? Any number greater than 0. Yes, you can pick any number. Let us pick 1, right? 1. So when x is 1, now what I don't want is to have any fractions here. I want to have normal numbers. When x is equal to 1, go to the original function. So the original function, we have f of x equal to what? We have been given f of x is equal to 1 over x. F of x is equal to 1 over x. So this is the same as y. When we're saying now, when x is 1, what is y? When x is 1, when I put a 1 there, it will be 1 over 1. So it's going to be 1 over 1, which is just going to be 1, right? So I have 1 over 1. And that's all that you need. Okay? The second thing that you need now is to pick any number. So 1 over 1. So let's draw this 1 over 1. So I've picked the number to the right. So I've picked 1. So we know that this is 1, right? Our 1 is here. This is our 2. This is our 3. We should have labeled them, right? This is 1. This is 2. This is 3. And then this is -1, -2, -3, right? So now, if I've picked 1 over 1, 1 comma 1, 1 comma 1 is right here, right? This is a 1 comma 1. So just from here, you have seen already that your curve should therefore be in this region. So in this region, you already know to say from this that I've drawn here, which I told you this is the way that they're going to appear. We have a curve that is going like this. So it's going to pass like this. Your curve is going to be like this. So meaning it's going to be wanting to touch this horizontal asymptote, but it won't touch. So it should come down like this, attempting to touch, but it won't touch like this. And then also up there, it will pass through this line, then it will go like this. You don't have to draw it to sketch, but you just draw it like this. Okay, then you would have drawn that point. Okay, so remember, this is going to be a general way that is they're going to come out. All of them, they'll come out this way that I've drawn, like this. Okay, so always remember that it's going to take any of these shapes, but only 2 of them will be appearing on the graph. So either this one, this region, or this region. Either only 2 of them will appear. So when you draw like this, then that's all. Then the next thing that you need now to do is find out as well, is it the other one, is it in this region, or is it in this region, or is it in this region? So since we have picked one, we've already found one. The next thing that we need is to pick the second one. Is it in here, or in there? So what we need to find out is, again, pick a number to the left now of the asymptote. Okay, so for the first one, we picked to the right, which was, we said any number that is greater than 0. And we picked 1. So now we're going to go for a number that is less than 1. So any number that is less than 1 here, okay, we can say x is equal to what? when we have x, since our horizontal vertical asymptote is 0, so any number that is any less than 0, we can pick -1 here, isn't it? So what will be y if this one is -1? So if we put x,
Negative.
it will be -1 as well, right? So we're going to plot -1, -1. So this is our -1, -1 is here. So it means it has shown you to say it will be in this region. Okay? So once you have known to say it's in this region, you check what you have here. Remember this thing that I've given you that is going to be here. It's in this region, and a graph in this region looks like this. So all you need now is to draw it like this. So let it attempt to touch, but not touch. Huh? So you just want to touch, but you don't touch. Huh? Then like this as well, it's going to go up, and it's not going to touch like that. Then you would have drawn, and that is all that they need from you. Okay, so always remember the first thing, get the vertical asymptote, get the horizontal asymptote. Then once you get them, put them on a graph like this, then now your key thing will be on the vertical asymptote. To know which region this graph is going to be in, you need to check the vertical asymptote. Pick any number to the right of the vertical asymptote. In our case, we picked -1, okay? And then you also pick we picked +1 on our right? Which was here at point A. Then you also pick a number to the left. And then when you pick that number, it will show you which region. And once you find that region, let it cross from there. Then you would have found them. And that is all that you need. Okay, any question at this point before I show you another one? Probably you can just do quickly. All good? Okay, let's try another example. What if now you have been given f of x equal to, so please watch this video on your own time, x over, this is now x minus 3, okay? Slightly different. So you can see this is 1 over x. Now we've just had the -3. So it's like the same thing we had, but now we've just put a -3. So when it's in the -3, you know to say it's going to change the vertical asymptote. So let's check the vertical asymptote, the first thing. So to find the vertical asymptote, what do we need? Vertical asymptote here, you just need to get the down part and equate to 0, isn't it? So it will be x minus 3 is equal to 0, meaning our x is equal to what? +3. So this is our vertical asymptote. What about the horizontal asymptote? To get the horizontal asymptote, so horizontal asymptote, we need our y value, isn't it? So you check now the powers. So this is just the same as x to the power 0, isn't it? So you can see here that it's bottom heavy. So our vertical asymptote, y is equal to 0, isn't it? Y is equal to 0. And that's all that you need. Go now to the graph the same way that we did it. We now go to the graph, and all we need is this and this. Just put down the numbers that you want. So the numbers that we want here, we know our critical values here. We have x equal to 3. So our x equal to 3, we have 1, 2, and the 3 here. So this is 1, 2. You can just put the 3 there. Then up there, what we need on the x values on 1, we can just put 1, 2, and the 3. Then you can also have 1, 2, 3. 1, 2, and the 3. The same way here, 1, 2, 3. Then you just have this. Then all that we need now is to find which region. So let's put this down. So to put this down, we need to get our values. So x equal to 3 is our vertical asymptote. So we go to x equal to 3. So I can extend this. X equal to 3 is here, isn't it? When x is 3 is here, so we're going to pass a line here on 3. This is our vertical asymptote. Please get a ruler. Okay, it should be a straight line, okay? So we have x equal to 3 there. Let me just extend it a bit. So x equal to 3 is our vertical asymptote. Then our horizontal asymptote is y equal to 0. So y equal to 0 will just be in this region. Y equal to 0 is just here. So y is going to pass like this. This is our horizontal. Okay? And that is all. So all that you need now is to now know which region. Is it in this one, or this one, or this one? That's all. So it's like you have your new Cartesian plane, isn't it? You see, this is the same as this. So now we need to check now the region that is going to accept. So all that we need now is to pick values. So go to the vertical asymptote. It's x equal to 3, isn't it? Which is here. So let's pick a number to the right, any number greater than 3. So let's pick a table of values. So we have got X and Y. So let us pick any number, just two values. Just one value is enough. We can pick two numbers or whatever. But let's just pick any number greater than 3. We can pick a 4, right? But all I don't want is to have a fraction number. When I have a fraction number, you can just redo it because it's better you work with numbers, isn't it? So let's pick X equal to 4. X equal to 4. What is our Y? Can you just please help me to calculate when X is equal to 4, what is Y? So this is our original function, right? What is Y when X is equal to 4? Can you just try it out? When X is equal to 4, Y will be what?
Y is equals to 1.
It's equal to positive 1, right? So I put positive 1.
Yes.
Then from here, just plot it. So what is 4 comma negative 1? Or 4 comma positive 1? So our 4 is here. We can put our 4 to be there. So we can pick 4 comma what? Positive 1. So this is 1, 2, and 3. So 4 comma 1 is right here. So you have already seen to say this graph is going to pass here. So all that you need again is make this graph go like this, as if it's attempting to touch that is not touching. Then the same way here, this is going to come like this, and it will be going like that, but it's not going to touch the vertical asymptote. Just like this. So, and this is going to extend like this. That's all. All right. The next one now you need again is to find out which other side is going to accept. So to check which other one again is going to accept, pick a number now to the left, isn't it? So let's pick a number now to the left. Which number? We can pick even a 0, right? Any number. So let's pick the one maybe closest. When X is equal to what? 2, right? So we have X, we've put here 4. So let's try 2. When X is 2, what's going to be the answer? So now the other table values, when X is 2, what's the answer? So when X, let's pick 2. What is our Y? When X is 2, Y is what? Y is negative 1, right? If you put,
Yes.
yeah, put here, Y is negative 1, right? So what is our point here? The point that we're having is 2 comma negative 1. So 2 is here, negative 1 is right here, isn't it? That's why I want you to draw them very nicely. So if our 2 is there, comma negative 1, so 2 is here, right? This is our 2, right? Negative 1 is right here. So we know to say it is in this region, right? So we have this, our region is here. So it's going to pass like this. Okay. And that's all. So you'd have drawn like this. Just showing this is enough. You would have drawn your what? Your asymptotes, and you would have sketched the graph. That's all. Okay. So maybe I'm having 5 minutes. Let me just quickly do another one if time can allow me. All right. So I want you now to, okay, can you please just mute your mic? I hope I can be able to finish this. So what if you have y is equal to 1 over x plus 2, then we have minus 3. So to get our vertical asymptote, we just check which value. So this is the same as x. So we know that this is the same as x to the power 0. So you can see it's bottom heavy, right? So to get our vertical asymptote, just need the zeros, isn't it? So we'll say x plus 2 is equal to 0. So our x is equal to negative 2. So negative 2 is our vertical asymptote. What about the horizontal asymptote? It's bottom heavy, right? So since bottom heavy, it's just going to be 0 minus 3, which means y is equal to negative 3. So this is our horizontal. We go to the graph, put down this, right? We're going to plot these so we can put down our asymptotes. So our asymptotes here, the first one that we have concerning our asymptotes, what we have is what? Our vertical is negative 2. So we put our negative 2 be here. So we can put this as negative 1. So our negative 2 is right here. So this is our vertical. And you put it down like this. What about the horizontal? Our horizontal is y equal to negative 3. So y equal to negative 3, this can be a negative 1, negative 2, negative 3 can be here. So if we put this as our negative 3, our thing is going to end up right here. Okay. And that's what we have. Aircraft, how long have I been gone? Were you able to hear me? Hello? Benny,
Yes, sir.
were you getting me?
No,
Huh?